Hey everybody, good evening. Here we are in session three. Oops, let me get rid of this whole thing taking up the screen. How do I go back to my screen? Here we go. Nice. No, that's not what I wanted. Minimize that. Well, we'll see how this works. Okay. So here we are in session three. Welcome back for the second week of the Joy of Coding here at Portland State University. Um, Last week we got set up with the course. We learned all about the structure of the course, all the syllabus, all that first day stuff. And then we started coding, and that was last Wednesday where we broke ground on the Java koans. Hope everybody had an opportunity to get started on them yourselves, and I'll take questions about that shortly. But I want to talk a little bit about this week, what's coming up next. So tonight, we actually, this week is kind of all about, well, it's test-driven development and pair programming. Really two very foundational topics for the course. Tonight we'll be talking about TDD. We'll be looking at unit testing. I hope everybody had a chance to review the JUnit lecture. That'll introduce you to a lot of the syntax that we're seeing tonight. Of course, happy to take any questions, but really the lecture, the screencast will give you the all the background that you need to not only understand what you're seeing tonight, but also apply unit tests in your own projects. And then on Wednesday, we'll be doing a pair programming exercise. Brave volunteers will be pairing with me to show what pair programming is all about. And so please also be sure to review the screencast for that in preparation for Wednesday. Before we dive into tonight's topics, where we do some test-driven development, I want to open up for prime minister's questions. What can I tell you? What were your experiences like over the weekend? Anything you'd like to discuss, ask me about, or provide me with feedback on? Yeah. Oh, okay. Good question. The quiz, yeah, right. The first quiz is due on Wednesday. The quizzes are always due for class on Wednesday. I think you only get one attempt. If there's something that you mess up or whatever it is, please let me know. I can always give you another attempt. It's about Git, yeah, so it should be stuff that's either you're familiar with or you can pick up from the lecture. Let me know what your experiences are. Usually students, I don't remember, I can do like 35 minutes or something like that. Usually it's more than enough time for folks. But like if you find that it's like, oh, this question was tricky, or it's like, something happened with Canvas in the middle. I've had lots of students that like started and all of a sudden it's like, oh, it's been open for like 6.5 hours. Oopsie. We'll get it worked out. No, I mean, really, the quizzes are supposed to be like what's in your head. Final exam will be open book, but like the quiz is really supposed to be what's in your head. And so then my expectation is that what's covered on the quizzes is sort of foundational enough things that if you've worked with Git, even just if it's just working with it on your koans, it should be sufficient to answer those questions. But let me know if it's not. So if you're like, I was really tempted because I didn't know this topic because it seemed a little esoteric, please let me know. Yeah. Great question. Thanks. And I'm going to try to learn people's names this term. So sorry, your name is? Sorry? Ed. Oh, yeah, Ed. Yeah, welcome. Please change some emails. Thanks, Ed. What else can I tell people? What else is going through your brains? What else would you like to know about? Yeah, that was, yeah. I know that was a great observation. Yeah. And so then, sorry, I forget your name posted on the slide. Yolene, yes, hi. So yes, I really appreciate you asking that question. Those are exactly the kind of questions I love to see on the forum, where it's like, oh, hey, I saw this thing. It's about the language, nothing, specific or private to you or anything like that. I expected to see this, but I actually saw this other thing. Help me understand why. So not only was it a great question, I like the way you asked the question. So thanks for doing that. But you pointed out an interesting thing about the language, where the literals for numbers, some of them have a little letter after them to say, oh, listen, if I want to have a literal long, it's got an L at the end, or what's the other one? Long and there's a little byte, but there aren't ones for like bytes or shorts. If I had to, I don't know why exactly it is that way. My guess is that the language authors, well, decide what's really necessary, and so then it's much more likely that you're going to have a literal value for a 60-bit. So by default, without any, by default, a literal value is an integer, is an int. It's a 32-bit, whole number. And okay, if you have a literal 64-bit number, then okay, you put an L after it, and that makes it a long by default. But then yeah, every other time you got a cast, which is actually kind of a good reminder of the fact that literals are ints, and so the fact that you need to explicitly cast, an int to a short, is probably a good reminder of the fact of that fact, and then also a good reminder that hey, you can have a literal 32-bit literal, which is bigger than a 16-bit short. So you got to be explicit about it. So that's why I think it's ultimately a good thing, but I agree that it's surprising the first time we see it. Oh, question here from Alex. Yeah, about the about objects koan in homework, and more specifically about the statement return ancestors.toArray new class. Yeah, Alex, what can I tell you specifically about that? Well, I'll go and get the code up here. About objects. Let's see here. Ancestors. Oh yeah, there's a lot of stuff about classes and stuff. Yeah. Let's see here. Ancestors dot to array. Okay, yeah, the get ancestors. Yep. So Alex, what exactly can I tell you about this? And feel free to come off mute if that helps us have a more effective conversation.
Okay, yeah, I'm just kind of wondering like about the syntax, I guess, like new class array.
Oh, yeah. This syntax right here, yeah, for
Yeah,
creating a new class, right? So this is saying, hey, create a new array of class objects, and this little syntax right here with the two braces basically creates an empty array. So that's interesting. That's kind of
okay.
yeah, you're right. That is kind of a unusual syntax. Usually we would just say like class of zero to have an empty array. Oh no, wait. Sorry. Wait, what is this? Yeah, a new class array of size zero. Um, yeah, interesting. Or we would probably say something like a new class array. So what? Okay, so this is like kind of week four, well, week three. Yeah, you'll see it in your first assignment. So this code has it has several concepts that kind of might blow your mind. One, of course, is the class, and we talked a little bit about that last time, the meta class, and how every object knows what its class is and represents it by this instance of a class. And then the other one is a list. And a list is basically a growable and shrinkable array of objects. You can think of it that way. You'll learn all about them in the collections classes. You'll actually be using collections in your first assignment. So you'll see it pretty shortly here. And yeah, what is this saying here? Is it saying, hey, yeah, okay, and then it's using a list, a collection type, and then it's using a type parameter, so they're strongly typed lists, and then it's got the question mark. So, yep, this is pretty advanced stuff for the first day. So you're absolutely right to call it out as like, what the hell is all this about? But basically, what it's saying is that I'm creating this list of classes, and the class itself is parameterized and can be any type of class in there. This will all make much more sense in about 4 weeks. And we're going to make a list there. And list is an interface. It's a non-instantiable type. And so you need to assign it. If you're going to assign it a real object, you need to create a new array list. Array list is a type of list. So it's a class that implements the list interface. And so then this creates an empty array list. And of course, it can grow as you add more stuff there. And so then what it does is it adds, it goes through the class hierarchy, basically, using the reflection API, and gets information about all of the all of the classes in the class hierarchy for this particular object, adds them to the array, sorry, adds them to the list, to the array list, and then returns an array of classes that's created from that list. Lots of stuff. Yeah. Oh, yeah, good point. This tilde right here, actually, that's an IntelliJ-ism. Yeah, there's not actually, it hides the code because it's not necessary to have anything over here anymore. So actually, these days in newer versions of of Java, of the Java language, you can just say just greater than less than here, and the compiler will infer what type needs to be there. Actually, the compiler doesn't really care so much about what's over here on the right, as much as it does here on the left. It'll make sure that if you do specify something here, it is assignable. So if you say, a new array list of integer, this won't compile because an array list of integer is not a list of classes. Great questions.
Okay, thank you.
That's Alex. Sorry, your name is Ollie. Excellent, thanks. Okay. What things you want to talk about? What things on your mind? What things you want to let me know about? It's so hard not to ask any questions because that just kills the competition right there. I get creative. Yeah. Mhm. Great question. And sorry, your name is Shanice. So Shanice asked a great question. We saw that we created the new project on a PSU machine and then commit and pushed it to GitHub and then pulled it down on a local machine. Is all that necessary? Can I just use IntelliJ to SSH in or remotely access the files on the PSU file system? Yes, I believe you can. I think I've had students do that before. If that works for you, great. There have been situations where I've tried to do that. It hasn't worked that well with me. I'm just slow to move things back and forth. And I'm trying to demonstrate, using Git to move things around. But if you sort of understand the concept of Git push and Git pull, then feel free to do whatever works well for you. And as long as you're committing to the repository, everything should be okay. And actually, that has a nice benefit of if you're also then running the code on the PSU machines, then you can be very confident that things will work when they're created. It's on the same machine. Okay. Thanks. Other questions, comments, things you want to raise?
I have another question about the new class array because if we're returning ancestors, wouldn't we like just append the class up like the class I don't know I'm not
Yep.
really understanding that.
Yeah, that's what we're doing right here. I
Yeah,
know, right?
yeah, right. But then
Yeah.
like when we do ancestors.toArray, we're putting an array and creating an array from in ancestor or
Yeah. Yes. You can also, I think you can also do, can you do that? No, it doesn't. Okay. So for whatever reason, and actually maybe the documentation will tell us, the toArray method takes an array to copy into. So probably, the thing that I've done the most is to do something like this, ancestors.size. So the whole idea, and you don't need that window syntax. This basically says, oh, listen, copy the contents of this list into the array that I provide. Matter of fact, it is highlighting something here, and it's saying, no, okay, so it doesn't or like it's recommending against sending in an array with a specific size. Okay. Um, but yeah, the documentation here. So I hovered over the two array method, and it brings up the documentation for it. It explains why, or rather this pattern. And so then yes, what you do is you say two string with a zero sized array. Um, the array into which the elements of the list are to be stored. If it's big enough, otherwise, a new array the same runtime type is allocated for this purpose. Yep. And this is kind of a weirdo method. I gotta admit, why it needs you to pass an array. Um, I can't explain. Yeah, this is a really old API, and so maybe it could be improved. So this is one of the situations where it's like, yep, let's make a practical call and say, hey, great, it works. Move on to bigger and better things. Oh yeah, sorry. Okay. Any particular line? I'm trying to think. Dot class. Oops. Great. Yeah, yeah, yeah. And actually, that's the whole idea here. So let's see here. This one is probably a capital I integer. Yeah. And then eight line 12. Oh, sorry. Here it is. Yeah, yeah, yeah. Great. What is the difference? Okay. So the primitive, and I go into some details about this in the Java language review lecture. The so-called primitive types. That's your little int, your little d double, your little b boolean, little c char. Uh, those are those are not object types. When Java first came out, they were trying to they were very sensitive to the runtime performance, the memory overhead, and also familiarity to C programmers. That's who they were targeting. So a bunch of C programmers, and C programmers like really care about space as they should. That's what C is really good at. And so then the language designers wanted there to be these highly efficient looking primitive types. And so they had little int like that. And that was, that was necessary for the early versions of Java, but very quickly people realized they want to use these primitive values in places where you can use objects, like in lists or in hash tables or really any place that uses objects. So in like an early revision to the language, they added those like capital I integers, capital B booleans, which are classes which are objects that then represent those primitive values. And so now you can use a capital I integer, in hash tables, in lists and vectors, all those kinds of things. And so that's why they have each. Now, for completeness in the type system, yeah, you want to have a Java Lang class that represents the little int. Because one of the things in that reflection API is that you can do things like, hey, give me a description of all the methods on this class. Well, if you have a method that returns a little int, what is how do you describe the type of that little int? Well, it's going to be int.class. So there's a class object there. It's all pretty esoteric stuff. And now that, I'm glad you're encountering it on the first day. It's kind of neat. It's not going to be indicative of the kind of stuff that you do here in the course, but that's what's going on there. So it's really, I think if there's one of the takeaway is that, okay, there's some complexity in the type system in Java. Again, caused by the fact that, yep, in the initial versions of the language, they wanted to have, clearly optimized looking primitive types. I'd say these days it doesn't matter so much, but yep, that's a little bit of the baggage that the language has. Yes, capital, right, right, and yeah, finish that. So capital I integer is an object. It descends from Java Lang object. It's got all of the methods and things like that. So yeah, you can invoke hash code on capital I integer. You can't invoke any method on a primitive. Sorry, your name is? Jay. Thanks. Yeah. Sorry, about loop, is that what it was? Yeah. 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 Oh yeah. Yep. So yeah, this is something, and again, these are sort of the more esoteric parts of the language. So you're probably all familiar. Continue from C++ or C, or maybe even Python has something similar to it. right? So the whole idea is that you're in a loop and you're like, oh no, just go to the next one. Well, what happens when you have a nested loop? So you can have something called a label in Java. And so this says, hey, listen, the count is greater than or equal to 2. Continue not to the next one in this for loop, but in the one that's labeled by 4. Actually, this is something I think they have in C and they decided to carry it forward. Honestly, I've never used this in my entire career. I've only seen it like 4 times. But hey, it's there in the language, and so there's a call on that. Let's see, it was something like this, where you've got like nested loops. Um, and hey, you're iterating over one thing, and then you're iterating over something else. And then you want to, usually it's like a matrix or something. And so hey, you're on this row and they're looking at every column. And then I don't know, you find what you're looking for. And it's like, well, I'm done with this row. Just go to the next row. And so you have to, increment the outer. Yeah, again, not a language feature that I've used very often, if at all. Nice. Okay. Lots of great questions. And I think you've all broken the record for the most interesting questions about the Java koans. It gives me hope that you'll get it done in a timely fashion. I hope they were compelling for you and or, give you an opportunity to explore the language and that you're feeling a little bit more comfortable with all the various things. I'll be showing off I'll be doing some programming tonight in front of you all, and I'll give you more of an opportunity to say, hey, what does that language syntax mean? I mean, you'll see, oh, that's how things are done idiomatically in Java. Ooh. Anything else before we move on? Cool. Okay. So tonight I want to talk about test-driven development. Actually, I want to show you test-driven development. So and actually I'm going to do this with the help of a handout. So let's see here. I'm just going to get rid of these things for the time being. I'll make this a little while. Oh, and of course, soon they do someone chatted something. Very good. Okay. And let me make this a little wider. Okay, there we go. No. Okay, there it is. Great. Okay. So for several years now, I've been using this Project Zero class. This is a project that I used to use a million years ago, and now I just use it for demonstration purposes, where you develop a simple program that models a student. And what I'm going to do is I'm going to create a new project in my repository for this student code. You do not need to do this again. You want, but it's not at all required. And then we're going to implement some tests for that code. And yeah, let me talk about sort of the methodology that we'll be using for capturing the tests, and then we'll look at the assignment itself. So and the whole thing, what we're going to do is we're going to work collaboratively to identify the test cases that ultimately will implement in the code. So when it comes to expressing expectations for behavior, I find that the given when then format is super simple and actually quite powerful. So the whole idea is that when it comes to capturing a scenario, a behavioral scenario, there are really 3 aspects to it. First, there's the given, which is like these are the initial context, the starting conditions for the behavior. So this is like, well, the setup part of your test. So it's like, hey, listen, previously on my test case, I'd done this, and this is sort of where we're starting. And that's often important, right? You need to maybe create some data, or get some test data. You need to put it together in one configuration, and then you actually perform the test. That's the when part of the clause. So this is the thing that you do in the scenario. It is the what do I call the event or the action? Like, oh, I called this method and I saw this result. And then the last part is called the then. This is what your expectation is. So, when I'm in this situation, when I perform this behavior, then I expect a particular outcome. So this is where, okay, you say, great, I called this method, I got this result, or I called a series of methods, and now my program is in this state. And this is the approach that we're going to use tonight. for capturing test scenarios for our simple student program. And I like this a lot because well, it's plain English. It's something that pretty much anybody can read, and so it makes it easy to collaborate. And it also is more familiar than the code itself. Don't worry, we'll be turning these things into code. We'll be implementing them as unit tests and later as integration tests. But in terms of approaching it, I found that given when then is very helpful. This given when then, I'll leave it on the screen here. Syntax actually comes from something called behavior driven development. And here are some good references on this. There are also testing frameworks like Cucumber and JBehave, where you can actually write these scenarios in given when then form, and then with a little bit of work, you can turn those into automated tests. The goal here, and I've seen it realized, but not always, is that someone who themselves isn't a developer, isn't familiar with the code, can specify a scenario. Someone who's like close to the customer or is the customer themselves. And this is really, really powerful. One of the things that I've found is that one of the hardest things that we do in software developers is try to express intent. And it's not our intent, it's really our user's intent. And so then, the more tools that we have to be able to set expectations, the more likely we'll be to get them right because we know what's expected. And that's what I really like about automated testing. What I love about test-driven development is that the first thing that you do is you lay out your expectations. And honestly, once you've done that, well, it's just a matter of coding. Now, that's always easy, but really, once you've gotten over the hurdle of like, well, this is what I want the code to do, problems become much more easy to solve. So what we're going to do now, after we'll walk through the student program, and then what we'll do is we'll break up into groups of 4 or 5 people. So probably like, I don't know, 2 groups here in class, and then probably we got 8. So we'll do 2 groups on the Zoom, and then populate some tables down here on the page with our test scenarios. Before we do that, let's take a look at the assignment itself, and I'll post this in the well, actually, no, it's on the Google Doc. So, I posted a link to the Google Doc in the Slack. Hope everybody got it because we'll be collaborating here in class on it shortly. Oh, why did I post that? Okay. So, Superworld project where we're learning how to extend a class. And so then, the idea here is that you've got one class in this project. It uses the human class, which is from the lecture notes in the EDU PDXCS Joy Lang package. And here's what that class looks like. So there's a student that extends human, and a student has a constructor that takes several properties of the student, including the student's name, the classes that they are taking. Oh, and this is an array list, kind of like what we just saw. The student's GPA represented as a double, and then the student's gender that can have 3 values: male, female, or other, and a note that is case insensitive. So these are the inputs to the student class. This is how you create a student. And then the student has some behavior that initially is unimplemented, but part of the assignment, part of the project that we'll be doing tonight is implementing that behavior. So every student has a says method. They say something. What do the students say? This class is too much work. You'll probably agree. There's also a toString method that describes the student, and there's some detail later on in terms of what that description needs to be. And then there's a main method. Now, as you may have already known, or maybe that you learned about in the Java language review lecture, a main method is where a program starts in Java. It's equivalent to the main function in C. And main takes 1 argument. It's an array of strings, and these are this is the command line arguments to the Java JVM that's running this main program. And out of the box, it prints missing required student information. But very shortly, we will see how to work with this. Maybe we'll just do that right now. So, because you'll be doing it in your projects, I just want to show you how to get started. Sorry, because you'll be doing it for your projects using a different script. I do want to show you again how to get started with this project here. And so then we will, let's see, we're going to log into the PSU machines as me. We're going to go to my checkout for the Joy of Coding winner 26. I'm going to do, actually, I'm going to, and then just make it so I only type my password once. Great. I'm going to do a git pull. Oh, I did have some changes, right, for my colons. That's good. Okay. So now over here, I'm going to run the create student project. But on Wednesday, we'll learn about the create first project script that you'll be running. This is just like how you create your koans, essentially. What it does is it creates a new child project for a student. You're happy to follow along. You don't have to though on this part. You won't, you're not required to do anything with the student project. Okay, it added a new student directory and it modified the pom.xml to show that. Yep, it added a new student module. So now I have two projects here. I have koans and I have students. Good to know. Okay, and so now I'm going to add those to Git. And let's look at status. Cool. Looks like, yep, came with some files out of the box. I'm just going to commit those. So I'm going to say added student project. And I'm going to push it up to GitHub, as is my preference. Again, if that's what we were talking about earlier, if you want to just edit the files directly on the PSU machines with IntelliJ, or I guess you can. So I'm going to quit out of that. I'm here back at my my checkout on my local machine. And now I'm going to do a git pull. And that brought in, yep, the student classes, the student files, and the pom.xml. All good stuff. Okay, so right, what I did there, and this is kind of what I did for the koans, and you guys did it too, right? Create the project on the PSU machine, commit and push everything to GitHub. Meanwhile, on my local machine, pull those changes down into my local checkout. Again, I like working on my development machine. I'm going to go over to IntelliJ. So I just added that there. And now when I go back to my project, you'll see, so in the background, IntelliJ updated because notice there were more files there. And now I've got a student project. It's a project because it's in bold. And so I can go look at the source and the main directory. Yep, there's a student class. And this is exactly what was there in the PDF. So, okay, good. And I guess I should probably also, I don't know, I'll just do a Maven clean verify, which is my way to just sort of make sure everything still works. Maven W. And so we'll let that run here in the background. So I hope this seems familiar to you, either by creating your own koans project or what we learned about last week. Anything that's making you wonder or ponder that you want to talk about what you just saw? Okay, good. Okay, meanwhile, this is running, and I did it from the top, and I ran the Maven command from the top level directory. So it's building all of the projects. So far, everything's looking pretty good. Okay. Yep, let's take its own time. And actually, you know what? I guess we didn't really talk about yet is what Maven is doing. There are a number of phases in a build project, and you compile the source code, you build an artifact like a jar file, because we need to talk about what that is, and then it runs the tests. So it does all sorts of things to build the project, and we saw all of that go by just now. So actually, now that we built it, let's run the Java program. So Maven creates a directory called target, which contains all of the built artifacts. So it's not the source code, it's like what's built from the source code. So your class files are in here, it's got a bunch of reports, and what's also here is jar files. Now, jar files are Java archives. They're like tar files for Java. So it's a whole bunch of files that are glued together, and these are the class files. So as you may recall, Java source code is compiled into class files, which are binary files that are the bytecode that execute on the Java virtual machine. And this is what makes Java platform independent. So the jar files, the class files themselves can be run on any Java virtual machine, regardless of what native operating system platform, operating system and hardware and chipset platform is running on. Okay. So I have here the student program. I'm going to get a little bigger. Yep. And it's got a main method. And the main method just prints missing required student information. Now I can run this program by invoking the Java virtual machine with a Java command. I say -jar to tell the JVM, oh, here's the jar file whose main method I want to run. It's going to be in the target directory, and it's called student.jar. And when I run that, it prints out this missing required student information to standard error, which is exactly what the main method does. So this tells me that everything's built. It tells me that I can run the main method and that everything's building the way I expect. And this is the behavior out of the box, right? So you create the project and you get this out of the box. So to reiterate, what we did was we created the project. We ran Maven, the Maven clean verify, which rebuilds the entire project. So clean deletes all of any build artifacts that were there before, gives you a clean slate. And then it runs the entire build process all the way through the verify stage, which is kind of the final stage, which will compile the code, build the jar file, run all the tests, and make sure all the tests pass. That's what Maven Clean Verify does. And you'll learn much more about Maven in a couple of weeks. Has anyone encountered a build system like Maven before? Is this like a completely new concept? Okay, a couple people have used Maven or Gradle or I'm guessing. I mean, maybe seen some Makefiles before. You guys use okay. Similar in concept, very different in implementation. But the whole idea is just like in a Makefile, you've got various artifacts that are created from sources, right? So I'm guessing in Makefiles, we're like, oh look, here's how you express changing, creating a .o file from a .c file or .c plus CPP file or whatever. Oh, and now you're creating a .exe from these O files using the linker graph. Maybe that's still the example that they use, but anyway, Maven accomplishes similar tasks, but it's much more. Well, first of all, it's Java specific, and so you're doing different things. But it's also it's more guided. So it's not like you're starting from a blank slate. You're choosing from a menu of things. Anyway, sorry, I'm getting ahead of myself. For today, what you need to know is that if you run the Maven clean verify command, it'll build your project and tell you whether or not any of your code doesn't compile or any of your tests fail. Okay, so what we've done here, we built the project and now we ran the jar file. And every time we make some changes to our source code, we'll need to rebuild the project again so that the jar file is updated before we can run it, right? So like if I say, if I just add 2 exclamation points here in my source code, if I go and I run my Java program again, I don't see it. But if I do the clean verify, and I probably need to do the clean, but I will. It'll take a couple extra moments, but we'll see once I rebuild everything. Ooh, it takes me a while on my machine. You'll be able to run it. Yeah. Meanwhile, it's time for a question. Yeah. So, yep. Well, so we're not using Maven exec Java on this one. Excellent point. Right. It's the koans. Okay. Well, you just made a very important observation. So the koans are special. And the way actually you know what? I never thought about changing the koans to have an executable jar. Interesting. I'll think about that because that might be a much more congruent way to go. So sorry. When it comes to running the koans, we use Maven exec Java, which also runs a Java program, just runs in a different way, not from executable jar. No, nothing bad about it. Yep. Yep. So just double check, is there a student, jar in your target directory? And is it student dash 1.0.0.jar? Okay, sorry, you need to run the Maven. Sorry, I wasn't super clear on that. Yeah, well, you need to have the jar file, period. And so is there a jar file in the student target directory? Okay, so then run a Maven verify again from the student directory. Good questions. Oh, nice. Okay, so great. What did you change to make it work? Okay, yep. Well, you learned something. We all did, right? You got to look in the jar file lives in the target directory, not in the student directory. Now that I've done the rebuild and I run java-jar again, I run the jar. Now it has 2 exclamation points. Yay. So if like you run the command line program and you're not seeing the changes that you expect, maybe you forgot to do a Maven build. Okay. So we have created the yeah, we've created the project, we've run Maven Verify. Okay, here Maven Verify was the example. You can also clean it. And we have run the oops, this is be updated and say missing command line arguments. It says missing student information or whatever. And that's cool. It's what we saw so far. But that's not the desired behavior. Here's the desired behavior of our program. So the idea here is that we're looking to parse the input from the command line. So when we run our command line, oh, and by the way, backslash is the line continuation character on Unix. So, when we run the program with the command, with the arguments, Dave Mail 3.64, algorithms, operating system in Java. And so I'll just show it here on the command line. We'll see how that is. So when we run, so we run this, right now it says missing required student information. What we want it to do ultimately is print out a string that says the following. This is the toString of the student object that's created from these command line arguments. Dave has a GPA of 3.64 and is taking 3 classes, algorithms, operating systems, and Java. He says this class is too much work. So ultimately, that's what we're trying to do here. We take in the arguments on the command line. We will create a student object from those arguments, and then print out the toString value of the toString, the result of invoking the toString method of that student object. And we expect the output to look something like this. Thoughts? Does that make sense as a thing to do conceptually? Nice. Ultimately, where we want to get. We're going to use this as an example of arriving at this through test-driven development. Okay, let's talk about yeah. Oh, and actually, one thing I want to call out. We don't read from standard input in this course. So command line argument inputs always come from the command line. We're not going to read from standard input. So don't use system.in in this class. There's usually at least one person every term that thinks, oh yeah, just read it from standard input. It's like, no. This is CS 101. You know how to do all of that. We're just going to read stuff from the command line and make it. Okay. Let's go back to this. Okay. So again, what we're doing here is we're reading stuff from the command line, and we are creating a student object and then printing its toString. So what we'll do shortly is divide up into groups and brainstorm test scenarios, given when then test scenarios for really 2 types of scenarios. And we will divide up into groups. Some groups will be working on one type of scenario. The other one will be working on the other type of scenario. The first scenario involves testing the student class itself. So not the main method, just the student class. You have the constructor, you have the says method, you have the toString method. You want to, do all that. You want to have tests for that. So here, I don't know. I have this table where each scenario has a, each scenario has a number, and here we provide the given, the when, and then. For the student class, we're going to create a student with certain properties, certain attributes. And so the name, the classes, the GPA, and the gender, this of course all corresponds to parameters to the constructor. And then we're going to have the when, which is the operation you perform on that student, like invoking it says method or its toString method, and then the result that we expect. So for instance, this first test scenario is, hey, listen, when really any valid value is provided, it doesn't really matter, to the constructor, and we invoke the says method, the result is always this class is too much work. Right, that right there is a scenario, right? True. This is what we expect. So like, hey, whenever you have a valid student and you invoke the says method, it says and it returns this class is too much work. And also for the sake of demonstrating these scenarios, I've provided one for sort of the happy path that is specified here in the assignment. So given that you created a student whose name is Dave and is taking those three classes, has that GPA and that gender, when you invoke that student's toString method, then you get all that text that is specified there in assignment. The second scenario is kind of the soup to nuts. You have to implement everything in order to get that one to work. Now, it's important to know what that scenario is, but that's not where we're going to start necessarily, right? That's where we want to end up, but it's good to know where you're going. So then the people who are in the odd numbered groups for that activity, will be focusing on this. You'll be focusing on the student class and the student instructor and the says method and the toString method, and coming up with various scenarios. So like, hey, listen, when I'm giving it these inputs, when I do something, then here's what I expect. I want to pause to talk about your understanding of sort of the structure of this. Does the table make sense? Anything that comes to your mind that you want to explore a little further? Yeah. Yeah, two groups won't be odd, won't be even. Yeah, I won't figure out here. Yep. Nope. Odd groups take this entire table. There'll be another table for the even groups I'll talk about shortly. Yeah. Good questions. Yeah. Taking into account null, yes. If null is an input to one of these, say what should happen. And really, the whole idea here is that you're collaboratively working together to arrive at your shared expectations of the behavior, right? So it isn't just one person. So this is not individual work. This is group work, where the whole idea is that we want multiple minds on the problem, and this is where you can refer back to the PDF. It's like, well, what did it say there? Or you can ask me a question, right? The idea here is that you're brainstorming what the expected behavior of this program should be. Oh, I'm gonna check for in the chat. Nice. Okay, so then we've got a given when then table for the student class, and I don't know, up to 20, whatever. I don't know if you fill all of them, but if you do, great. We'll spend about 10 minutes doing this. And then the even number groups will be working on test scenarios for the command line program. So here you're thinking about the main method, but really what you're thinking about is running the command line program. So here, there's not much of a given. It's like, hey, given that your code compiles and you've got an executable jar, when you provide these arguments on the command line, then this is written to standard output, this is written to standard error. And test scenario number one, it again is that complete happy path where it's like you provide this information and then you get you get that text that's written to standard output. But as you can imagine, there's lots of other inputs that you could have to the program, and the goal of the goal of the exercise is to capture what you expect to happen when that data is provided, or when those arguments provided on the floor. So we're going to divide up into groups here shortly, but before we do, I just wanted to give you an opportunity to ask any questions you have. Let me know anything before we break up. Yeah. You tell me, right? That's a great question, right? It's like, well, has it? And you can either ask me, I'll say yes. Yeah, the student has a GPA, or rather, yeah, we don't need to account for students that haven't enrolled yet. But you can also make those kinds of decisions amongst yourselves. It's okay, right? You're brainstorming. I think what's most important is the conversation. Or not. No, there's not right or wrong answers. Almost being great. Excellent. Okay. Well, let's see here. Actually, let's take 18 minutes end to end. So let's see here. That'll be 6:32, 6:40. I'm going to open up two breakout rooms in the Zoom, and there'll be breakout rooms 1 and 2. So please choose an even odd appropriately. And here in the classroom, please divide yourselves into two groups and figure out who's even, who's odd. Cool. And yeah, we'll reconvene at 6:40. Oh, I don't have the audio going to the right place. The audio goes to HTML. Great. Awesome. Okay. So let's quickly just sort of like talk about what your experience was like. So for the people that worked on the, well, actually just kind of anybody, we'll just go like, we'll go around the room, but we'll start with people who are remote. So I think everybody who was remote ended up working in the same room. Nothing wrong with that. Tell me about your experiences. What was it like sort of brainstorming the test scenarios for the student class? Folks who are on Zoom.
I think the way that we initially just started handling it was different. And so we had to kind of all get on the same page.
Ah,
Because we all had kind of some different ideas how to do something. And so I think that was one thing I noticed.
nice. Others who are remote, like what is a story that you tell about your experiences working on this activity?
Oh, I feel like a good thing we did was obviously with testing just putting in default values that should work, but I feel like another thing about testing is entering in values that may not work, so that we can see how the error is handled and then also how we can handle it smoothly. And I feel like for this project specifically, since everything's being put in on the command line, we would smoothly exit since we wouldn't prompt them to re-enter through standard in.
Nice. Cool. Thanks. Any other thoughts from folks who were on Zoom? Okay, because they're here in the classroom. Let's start with this group up front. So let's see here. This was the odd number group. So yeah, what were your experiences like? Oh, so we kind of went for the extremes, like the kind of weird out there. And why was that a mistake? So I let's see.
Well, because I didn't think that, like, I sort of first paid attention to how it's transformed the timeline arguments, because, like, for instance, if it's missing a name, is it going to be thrown there, or is it going to think its first name is output? Is it something like take on first name to put it in on here, because it has to kind of the timeline arguments is to accommodate related fortunes, which is an awesome group. But then after the video, that's the class that set up so that it has a string name.
Right, because the constructor.
So
Okay.
it's arranged in a way that
Good learning there. Yeah.
it handled that so that like it took a little bit. It's not.
That's good. Yeah, that's great. Thank you. Other observations from this group? Anything noteworthy? That's fine. And the group in the back that worked on the command line. Yep, nice and good. Came up with plenty of scenarios. What was your experience like? What was challenging? What was easy? What was maybe head scratching?
We also talked about how the parts of the whole along
Yep.
how we I think parts of it as well. New classes.
Hmm.
How it works. New classes.
Right. Again, exploring the boundaries or what's out of bounds, what's inbound. Yeah.
Can't say it's, well, there's skate person. Say like, oh, this is always been done.
Emoji in their name? Sure.
Oh. So,
Yep.
no, not, I would still further down.
Afraid to look there. Oh. I'll refresh. It might be on my end. Oops.
That's a big point.
22. Oh yeah, look at all this. Look at all this. Nice. Nice. Well, okay, and that's that can happen. Yeah, yeah. Yeah. That's so. Okay. Mm. Okay. Yeah, yeah. Error message. Yeah, that's another. And actually, that's an interesting thing about the second table is here. The outputs are need to be meaningful to a human. Where up here, I think it's a little bit more code based. Oh yeah, have an exception thrown. Okay, that's not the same as having to craft an understandable error message. Good observation. Yeah, excellent, cool. Okay, good. I was just glancing at these look like good test scenarios. What we'll do is we will implement some of them as unit tests. But first, I want to talk about the red-green refactor cycle. So test-driven development has these three phases. So the whole idea is that you start by writing a test, and this can be very unnatural because right, I mean, none of us learn to write a test first. That seems crazy. Why would you do that? You write the test afterwards. No, try writing the test first. Because what it does is, you'll have an experience just like you did now, where it's like, oh, I'm really focusing on the outcome. Okay, and then I'll figure out how to make it work. But you know what the goal is, and so you'll know when you reach it, and that'll be good feedback. So, and really, what TDD allows you to do is, well, either find bugs as soon as they're written because the test doesn't pass, or never write bugs in the first place because you know exactly what you need to do with the test to pass. And what in test-driven development, you start off with having a failing test or the red in the red state, and then you make it pass by implementing the code that it takes to make it pass. And then there's a final phase called refactoring. Now we'll talk a lot more about refactoring in a couple of weeks. The whole idea is that after you get your code working, you take a look at your code and say, well, can I make the code easier to work with in the future? So you don't make a change, you don't make a functional change to the code. It's not you add more capabilities. Instead, you say, oh, do I have code that's duplicated? Do I have variables or method names that could be renamed to be more effective. And this is the cycle that you go through in test-driven development. So, I've got some text here, and you can read about it in the in the document. I think what I want to do, though, this will really drive it home, is I've got a little cheesy video to play. A little bigger. Here. Let's see here. And let's see here. Let me share the system audio. Let me share the system audio, which I used to be able to do from here. Those need to stop. Oh, wait. I'll just reshare it. I'll say share and share. Did we change it again? Oh, no, here it is. Share sound. You don't need to optimize. No, mono will be fine. And yeah, I'll optimize for video sharing so it'll come through a little better. Share my screen here. I'm going to start it, and please let me know if folks who are remote, if you cannot hear the audio, I'll let you know when it starts. Actually, you'll see Uncle Bob talking. This is Uncle Bob Martin.
Oh, it's time for the red-green refactor cycle, and I am in the red phase. I must write a failing unit test. All right. What test must I write that will force me to write public class game? Well, I'm going to write can create game. Game G equals new game. Oh, heavens. Thank you, IDE. Helpful IDE. That's enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look, the test passes. It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No. Nothing to refactor. Very good. Then I am done with this test. I am passing. Lovely. Back to the red phase. The next test, well, I know I want to write that roll method. All right. Test can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll. What should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that, roll. And it should take a pins. This is lovely. And I believe that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case. Back to red. Well, what can I make fail now? I got to write the score function. But I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0, I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes, and now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
Okay. Happy coding. I know it. So, what did you observe in that video? Like, what stood out to you as something that was either surprising or something that was confusing or something you just you're still pondering, other than like the silly hat? Or maybe the silly hat. What's this? I don't want to know. Don't know. A couple people. Yeah. Yes, that is a great observation and a really important one. He only wrote as much code was absolutely necessary to make a test pass. That is a key behavior in test-driven development, and it takes so much discipline, right? Because I know I'm like that. I'm sure you are too. Where it's like you have like you are like 5 steps ahead. You're like, oh yeah, I know exactly what I need to do. I know exactly what I want to do. That's what's so fun. But my experience has been is that you do that, and then until you get feedback from a test, you know if you've done it right. And so then I think what I've learned over the years is like, I'm not as smart as I think I am. And so then the tests, though, tell me when I've got it right. The tests tell me how smart I am, which isn't very smart. Anyway, good, great observation. Others? Who else raised their hand? Yeah. Oh, yes, you noticed like how much he relied on the IDE. Yes, and I think it's just programming in general is a lot more tedious if you don't have the IDE, the tools, the keyboard shortcuts, the things that allow your fingers to go as fast as your brain. That's something that we'll see, or at least I hope you'll be able to observe when I write code, is that yep, I leverage the tools that I have so that I can go fast. Yeah. Other observations? Yeah. Oh wow, another great observation, right? So like if you already got code, adding tests after the fact, kind of tough. Like, yes, it is, but it's also fact of life for a lot of people, right? I'm sure sometime you'll encounter a code base where it's like, there are no tests, or there's like an important part of the code and there's no tests. We'll see an example of that in the refactoring kata that we'll do in a few weeks, where like you get this incredibly ugly piece of code. And your goal is to make it better. And the first thing that you should do is write some tests for it. So that way, when you change that code, you'll know that it still behaves the same way. Great observations. Other observations on the video, yeah. Why you write everything from tests? Like, you're not. Yes, I think that's the most important word, right? So it's like, where do you start? And like, do you start by like taking all the ideas that are in your head and writing them in the code? And it's like, great. And then how much time do you spend debugging it? Because there's something that you missed. or like you realize like, oh wow, there's a way better way to do that, and then you bring a whole bunch of stuff apart. I think the idea here, and the idea with test-driven development is that you work in very small increments, take baby steps, and that's how you end up, walking a mile. I'm really curious to see what your experiences are like, because everybody experiences TDD slightly differently. Some people are like, oh wow, this is life-changing, is it? And other people are like, this is really awkward. I don't like this, and then that's fine. But part of learning is experiencing and trying new things, and so I'd like you to understand enough about the approach and the mindset of test-driven development. Try it on your own. We'll be doing it. I'll be showing you more of it here shortly. But yes, it's a learning experience. Okay. Okay, now let's go back to the test scenarios and the code that we had written for the student class. And let's start implementing some test scenarios. Let's just start with the first one. So let's see here. I'm going to make this a little smaller. So I'm going to do a split screen with my student in one pane and then my test for a student. So actually, yes, something we didn't really talk about is the layout of this project. There is, you've got the main source code here with the student class. And then there's another directory with test Java, edu, pdx, csjoy, whitlock, which is the student test. So I'm going to open up the student test, make it a little bigger. And I'm going to put the code side by side just so we can see it. I'm going to put the, let's see here, I'll say split and move right. Great, we've got the student test over here. Make it a little bigger, make this a little smaller. Hopefully it's not too small. That looks okay. It comes out of the box with one test. And it's called student name Pat is named Pat. So here we create, this is a test, and it's test because it's annotated with @test. And the name of the method is that. And what do we do here? Well, we create, we have a variable called name. We create a new student with that name who takes 0 classes, has a GPA of 0 and a gender of doesn't matter. And and then we make an assertion. The syntax is a little different from what Uncle Bob showed. This is from the Hamcrest API. If you haven't watched the JUnit lecture, I encourage you to do that. And we should say the following: assert that the value returned by pat.getName is equal to the variable name. And so here's the test, and we can run the test by clicking this run button that's here in the margin, and we can run it or debug it. We're just going to run it for now. And so this tells IntelliJ to run that test. So it'll compile the code, and it'll run the test. It's the first time it's building, so it's taking a minute or two. What it'll do is it'll pop up yep, there we go, in a window for running it, and it said that all the tests pass. So good. Their student name Pat is Pat. So I hope you're seeing the given when then in this. So the given that, hey, I've created a student with this information. When I invoke pat.getName, then I assume that I assert that the value is equal to the name variable. So this is what a unit test looks like, right? You create a little data under test, you perform some operation on that test, and then you assert that the outcome of that operation is what you expect. So out of the box, we had a passing test. We're already in the green. Probably nothing to refactor here. Let's write a unit test for this first, for this first scenario where we provide valid values as the parameters, and when the says method is invoked, the result is this class is too much worth. So I'm going to say the following. I'm going to create a test. I'm going to say all students say this class is too much work. Oh, thank you, AI. Let's see here. Did it get it right? Actually, that's a pretty good, yeah, that's a pretty good test. Okay, nice. Let's go with that. Let's run it and see what happens. Okay, it is failing. So what I do, it created a new student. And I don't know if you can see here, but the call to the says method is underlined in red because this is where the exception was thrown. This is where the test failed. So says through an unsupported operation exception not implemented yet. Okay. I want to go look at the implementation of that says method, which I can do by saying go to declaration or usage. Yeah, here's the says method. Okay. Right now, out of the box, the says method throws an unsupported operation exception. What should it do instead? It should return, yep, this class is too much work. Return, this class is too much work. Ooh, IntelliJ knows me too well. Great. Let's run that and see it pass. So it was red. Now we want to make it green. Awesome. And now we want to refactor. Any opportunity? Anybody see any opportunities to refactor? Yeah. Oh yeah, I like that. Yeah. Yeah, we could put this into like a field like he did, right? He had the game in a field. Um, I think I think I'd prefer an approach like the following. I'd say I want to put this into its own method because there'll be lots of different students, so I don't want to use the same student every time because they're different inputs. So how about we create, and we'll go in more detail this later in class, and say refactor, introduce method. And this is and also get pat. I want to say get student named that. Oops. Oh, and it's telling me that there's other code block here that could also be replaced with that method call. Yeah, let's do that one. Let's replace that. And oops, it shouldn't be get student named. I typed it in wrong, so now I want to do a refactor and rename to get student named. Nice. Now I've got all this logic in one place. It's not duplicated code anymore. Now I made that change. I want to run all my tests to make sure that they still pass. And they do. Good deal. Okay, so that was a red-green refactor cycle, right? We wrote a new test. We saw it fail. We made it green by implementing the behavior that was expected. We ran the test, made sure it was green, and then we refactored. We looked for duplicate code and removed it. He hinted at this in the video. Why do you think it's so important to see it fail? Why not just like write the test, write the code, make it pass? Oh, it pass. Yeah. Right. So you know your test works. In particular, yeah, I mean you want to make sure that the assertion actually does what you think it does. I've made that mistake before, where I wrote the test, I wrote the implementation, everything worked, and then like 5 minutes later, I realized, wait, that was totally bogus. There was some logic error that made, well, either a logic error that made the test pass when it shouldn't, or more likely the test was wrong. I've made that mistake so many times where I'm sort of like not thinking and I implement a test, it doesn't actually test what I think it does. So taking that extra moment, just having that extra discipline to run the test and see it fail, make it red before making it green, will pay off. So I just wrote a test that passes, and I'm going to commit these changes up to Git and push commit them to Git, push them to GitHub, so I have a nice clean slate to start my next test. Yeah. Yeah. Yep. Oh, that's weird. So like what I did was, I highlighted the duplicate code, the code that I wanted to take out of, one context and put it into a method. And then I did refactor, extract, introduce method. Basically the code that creates the new student. Okay. Well, I do see we're running low on time, so I want to introduce one more. I want to write one more test to show something, and then we'll break. So I want to implement this second scenario. And so I'll do that right now. I'll just say test void Dave student. And then no, that's not what I want. Stop being helpful. So I want to say student Dave equals new student. And remind me again what this. So the name is Dave. We're going to have some classes. The GPA is what, 3.64. 3.64, and the gender is male. I want to create this variable right here. And so when I do on the Mac, it's option return. I get this little context menu here. So I can create a local variable that are the classes. That's great. And I'll create a new array list for that. And I'm going to add the classes, which are algorithms, operating systems, and Java. Algorithms, it's algorithms, yep. Classes.add. Nope. Operating systems, and see, it's like it's so close, but yet so hard. Anyway, great, Java. And now I want to assert that Dave.toString equal to, and I'm just going to put the whole, no, that's not what I want, the whole thing right here. I'll copy that in to here, 2 spaces after a period, because you know I'm old. And, but everything else here looks, oops, looks pretty good, except that I got the name wrong. So this is a nice end-to-end test. I'm going to run this test now. I like implementing this early because it just gives me a feeling for like ultimately what I need to build. Like here's the whole big picture. Not surprisingly, it fails because I haven't implemented the toString method yet. Oh, by the way, you get a stack trace down here, and you can click on the source code to go directly to it. Now, this is a perfectly valid test, but it's not going to pass for a while. We got a lot of code to implement. So I want to keep this around, but I don't want it to run. So what you can do is you can mark it as disabled. And now the test won't run as part of like the whole suite of tests. So now if I go and run all of the tests again in the class, it'll run the first 2, but not the third one. Nice. Okay. Well, I was hoping to show a little bit more tonight, but I want to respect everybody's time. And so that's going to be everything for tonight. So this is the introduction to test-driven development. We'll talk more about it on Wednesday. In the meantime, please focus in on your koans. And we'll do some TDD on Wednesday along with some pair programming. Looking forward to it. Hope to see you all then. Bye now.
Thank you.
See you later.
Thank you. Good night.